About a couple triangle angle theorems. Triangle angle sum theorem says that all three angles of a triangle add to 180. We're going to use that in a minute for a problem. And there is a corollary to that we didn't talk about in the previous video that says if you have a right triangle, then the two acute angles of that right triangle will always add to 90 degrees. It's kind of just a shortcut. If you know you have a right triangle, you can just add the two other angles up to 90 and have, smaller numbers to work with. So right here, we're solving for x in each of these, and we are also asked to classify it based on the angles. And that's something that's easily forgotten. Once you solve for x, you kind of move on and forget what to do. Classifying this by angles, I know immediately, because it has a right angle, that I can just name it right off the bat that it's a right triangle, but I also need to solve for x. So I'm using this rule over here that the two acute angles of a right triangle add to 90. So I can add x plus 2x equal to 90. And I can see that that's 3x equals 90. And dividing by 3 on both sides, x is 30. So in this particular problem, I'm getting 30. If I were wanting to find these angles specifically, I'd plug that in for x. And I would see that this angle is 30 and that this angle is 60. This is actually a special right triangle that we're going to see a lot later. Right triangle with angles of 30, 60, and 90 is very special. We're going to use those a whole bunch later on in the course. Over here on the right, there's no right angles, so we're going to need to use all three angles. And so we're going to be adding them all to 180. So I've got 2x plus 3x plus 55 equals 180 degrees. You can combine your like terms here, and you could combine before you write this down. I usually identify my like terms before I write the equation, and I combine them before I write it down. 2x and 3x combine to be 5x's, and then 55 was your constant over here. And together that all makes 180. So we're going to solve by subtracting 55 on both sides, and that would be 125 here, and then dividing by 5 on both sides, x will be 25. So x is 25, but don't think that you're done, because that's not the end of the problem. And often, people stop here thinking that they're totally done, but they're not. So I need to plug in that 25 and then classify this triangle based on its angles, because I haven't done that yet. So plugging in 25, 2 times 25 would be 50 degrees right there, and then 3 times 25 would be 75 degrees right there. All three of these angles are less than 90, so this is an acute triangle based on its angles. We've already written down the exterior angle theorem in another video, but we'll write it again. The exterior angle is equal to the two remote interior angles. So in this case, it's A and B. So we've got a couple of samples here to work out using that rule. Let me move it so you can see the rule at the same time. There we go. So on this first one here, this is the exterior angle. It's equal to the sum of the two interior angles that do not touch it, that are not adjacent to it. So I'm going to set up my equation as x plus 80 equals my exterior angle, 3x minus 22. And this is the equation I'll have to solve. So I'm going to solve by subtracting x from both sides. Gives me 80 equals 2x minus 22. Adding 22, 102 equals 2x, and dividing by 2, 51 is x. So I think all they wanted us to do on this problem was to find x. We didn't have to plug it in or anything. So for that one, x is 51. For this one on the right side, it's a little bit more challenging because these are expressions. And this one's the exterior angle there. So we're going to set up our equation as the exterior angle equals the sum of these remote interior angles. And I'm just going to write them all out for now, but I want you to notice that this 3 and this 51, you could combine those before you write it down. If you want to skip that first step, that would help. So if you combine these together, you get 54. because they were both positive. And now solving. So get my x's together, I move the fewer amount. There's less here, this 2x. So I'm going to subtract 2x from both sides. Gives me 2x plus 8 equals 54. Now to get the x's alone, I'm going to subtract 8 from both sides. 2x equals 46. And then to get the 2 alone here, divide by 2 because they were multiplying. And x is 23. So for that problem, x is 23. So that's just using the exterior angles theorem